So good evening, students. The condition is the block is sliding in a inclined plane. Whether it is sliding or not, or whether it is in equilibrium or not, we are going to determine. So the given problem is determine whether the block shown is in equilibrium and find the magnitude and direction of the friction force when theta is equal to 25 degree and the applied force P is equal to 750 Newton. Block weight is given as 1.2 kilonewton, and then the force direction is given, and then the inclined plane angle is given as 25 degree. The coefficient of static friction is given as 0.35 and the coefficient of dynamic friction is given as 0.25. As we discussed in the class, so first we are going to draw the free body diagram of block. In the given problem, so the angle is given as 25 degree. The inclined plane with horizontal, the making angle is given as 25 degree. The weight of the block is given as 1200 Newton. And then the applied force is given as 750 Newton. So if you are substituting all these values and with the inclined plane, so we will get the 1200 Newton, which is making an angle of 25 degree with the perpendicular line with respect to the inclined plane. Similarly, the 750 Newton, which is making an angle of 25 degree with the parallel line of the inclined plane. So we have to resolve the forces along the plane. So the first one, we know the equilibrium conditions. There is summation of horizontal component is equal to 0. Here we are going to resolve the forces along the inclined plane. So in that condition, so you know that the 1200 Newton, which is making an angle of 25 degree with the perpendicular line of the inclined plane, will have the component 1200 sine 25 degree along horizontal with respect to the inclined plane, and then the 750 Newton applied force will have a parallel force with respect to the inclined plane. That value is 750 cos 25 degree, and because of this 750 cos 25 degree, we will have a frictional force which is acting opposite to this 750 cos 25 degree. So 1200 sine 25 will act towards right, so it is positive, and 750 cos 25 degree is acting towards left, so it is negative. So the frictional force will act towards right with respect to the inclined plane, so it is positive frictional force. So based on that, we will get the equation 1200 sine 25 degree minus 750 cos 25 degree plus the frictional force F is equal to 0. So from that we can calculate the force value is equal to 172.6 Newton. So this is the first equilibrium equation, and then we are moving to the second one, that is summation of forces acting vertical is equal to 0. This is also with respect to the plane. So we are resolving the forces with respect to the plane. So now if you are considering, we will have 1200 cos 25 degree, that is the vertical component with respect to the plane of 1200 Newton weight, and then we will have 750 sine 25 degree, that is the vertical component with respect to the inclined plane for the force of 750 Newton. And then we will have one more important reaction, that is N. So now if we are writing the equation, we are considering that upward is positive with respect to the inclined plane. Then we will have N is positive and 1200 cos 25 and 750 sine 25 degree are negative according to the inclined plane, because 1200 cos 25 degree and 750 sine 25 degree are acting towards down and the normal reaction is acting up. So normal reaction N is positive, 1200 cos 25 degree and 750 sine 25 degree is negative. So we are equating to 0, so that we will calculate the normal reaction N is equal to 1404.5 Newton. So once we got the frictional force 172.6 Newton and the normal reaction is 1404.5 Newton, then we can calculate what is the maximum friction force by using the formula Fm is equal to mu s into N. There is Fm is limiting friction, mu s is coefficient of static friction, and then n is normal reaction. So we know the value of mu s, that is 0.35, and then we know the value of normal reaction, that is 1404.5. So by substituting these two values, we will get, so the limiting friction value is 491.6 Newton. So once we calculated the limiting friction, now we can relate the frictional force and then limiting friction value. Therefore, F is less than Fm, that is frictional force is less than limiting friction. So the block is in equilibrium. So this is the way we have to calculate whether the block is in equilibrium or not in an inclined plane condition. So next one, these problems are for your homework. So determine whether the block shown is in equilibrium and find the magnitude and direction of the friction force when theta is equal to 30 degree and P is equal to 150 Newton. The next one is determine whether the block shown is in equilibrium and find the magnitude and direction of the friction force when theta is equal to 30 degree and P is equal to 1500 Newton. Post your answer in the comment box.